In this video, we're going to look at the setup and alignment procedures for the new millimeter wave sensor system that performs vehicle detection in the intelligent cruise control and other driver assistance systems in the 2013 Infiniti JX35. We'll start with a brief overview of the system and the special service toolkit and equipment required. Next, we'll address how to prepare the vehicle for the alignment and the various precautions that must be observed. Then we'll demonstrate how to roughly position and set up the target board using the stationary target and the laser assembly, all provided in the toolkit. We'll follow that up with detailed procedures for completing the setup with precise aiming instructions. And finally, we'll show you exactly how to perform the actual alignment procedure using Consult 3+. The introduction of the 2013 Infiniti JX35 brings some changes in technology that enhance the safety features of Nissan and Infiniti products. One of these innovations is the millimeter wave sensor. This new device takes the place of the Intelligent Cruise Control, or ICC, integrated unit that used a laser sensor to detect vehicles in the lane ahead for cruise control operation, intelligent brake assist, forward collision warning, and distance control assistance systems. The millimeter wave sensor uses radar waves instead of a laser beam to detect obstacles in front of the vehicle. This provides more accurate detection without interference from road debris or weather. For the driver assistance systems to function properly, the sensor must be precisely aligned straight ahead. By straight ahead, we mean parallel to the thrust angle of the vehicle. To ensure this, the sensor unit must be aligned using the new ICC target board, laser assembly with bidirectional laser beam, stationary target, and the Consult 3+ application. This procedure must be performed after a four-wheel alignment, or after a collision, or if the sensor has been removed or replaced for any reason. The Special Service Toolkit, J-50808, will contain the target board, the laser assembly, and the stationary target. A Hunter wheel alignment adapter is required to mount the laser assembly. Prepare the vehicle by first adjusting the tire pressure to specification. For proper adjustment, all vehicle wheels must be undamaged and of the same size and type. Remove any cargo or heavy items from the passenger compartment, trunk, or cargo area that would affect vehicle posture. Before performing the millimeter wave sensor alignment, you must do a four-wheel thrust angle alignment to determine the thrust line of the vehicle. This is necessary to set the ICC target board properly for sensor adjustment. Be sure to make any required adjustments to the alignment settings. If an alignment cannot be performed, follow the detailed instructions in the JX35 service manual to set up the ICC target board. Now, set the Shift Select lever to the P position. The millimeter wave sensor on the JX35 is mounted behind the front bumper fascia on the lower right side of the vehicle. Clean the front bumper fascia in the area of the millimeter wave sensor of any dirt or debris that might interfere with the adjustment. The sensor lens should not require cleaning. There are some other points and precautions that require attention before beginning sensor alignment and during the operations. It is best to use a level location, such as an alignment rack, with a few feet of working space around and in front of the vehicle. The vehicle must be stationary and unoccupied during the procedure. Never attempt to enter or move the vehicle. Any movement will cause the procedure to fail, and the process will need to be restarted. The ignition switch must be on, and a maintenance charger should be connected to the vehicle's battery to keep the battery voltage up. The battery voltage must be 12 volts or higher during the entire procedure, or the procedure will fail. During the procedure, never block the area between the millimeter wave sensor and the ICC target board. Accurate steering wheel setting is crucial. Once set, do not disturb the steering wheel for the remainder of the alignment procedure, unless directed to do so. To avoid physical damage, the millimeter wave sensor adjustment screw must not be forced to either the clockwise or counterclockwise adjustment limit. For proper adjustment, follow the directions of Consult 3+ exactly as instructed. Place the ICC target board approximately 2 to 3 feet in front of the millimeter waveform sensor. This distance can be judged by stretching the gold and black chain from the ICC target board to the front bumper. This distance is not critical. As long as a gold link is touching the bumper, the distance will be appropriate. If a black link is touching the bumper, reposition the board so that the bumper contacts the gold area of the chain. Now, to roughly center the target board with the center of the sensor wave axis, adjust the vertical position of the target board by releasing the height adjustment knobs on either side of the target board. This may require 2 people, as the target board assembly is very heavy. Move the target board up or down so the center of the target board is roughly aligned with the sensor wave axis. Now, remove the metal cover that is protecting the mirror underneath, and position the laser assembly in the center of the mirror so that one of the laser openings points toward the millimeter wave sensor. Then, turn the laser on. The laser beam should be within 3.15 inches above or below the general area on the bumper fascia. Then, adjust the lateral position of the target board by moving the board right or left so the laser beam roughly aligns with the sensor area on the bumper. The beam should be within 3.15 inches right or left of the sensor area. Turn the laser off when done. If you are using the preferred Hunter alignment equipment with the target board setup software, follow the on-screen directions to complete the target board final setup. This method of alignment is easier and more accurate than the manual method which is used with other brands of alignment equipment. If using other equipment, it may be necessary to acquire a Hunter mounting bracket to attach the laser assembly to the right front wheel. In either case, the purpose of the final setup is to set the target board at a 90-degree angle to the thrust line of the vehicle. Ensure that the right front wheel is positioned parallel to the thrust line of the vehicle. To do this, remove the right front alignment target and install the laser assembly in the right front alignment bracket. Turn the laser assembly so it's close to level. Replace the alignment target in the mounting hole in the laser assembly. Now, select Mount Sensors and Compensate from the Hunter alignment software, as you will need to compensate the right front sensor for any runout from the laser assembly. You do this by rotating the right front target in the laser assembly to make the compensation. Do not jack up or move the wheel. Then, turn the steering wheel until the toe angle of the right front wheel is set to 0 degrees. The next procedure is to set the bidirectional laser assembly parallel to the contact surface of the tires. This may or may not be level depending upon the surface where the vehicle is placed. Place the stationary target next to the right rear tire, and then turn the laser on using the switch on the laser assembly. The laser beam should be emitted through the front and rear openings. If necessary, reposition the stationary target so the laser beam strikes the laser signal reception plate. Position the magnetic marker on the plate of the stationary target to identify the precise location of the laser beam on the stationary target. Move the stationary plate as close to the front tire as you can get, and note the laser beam's location to the magnetic marker. Rotate the laser assembly in the alignment adapter bracket so that the laser strikes the magnetic marker or stationary target at the same spot when located at the rear tire and the front tire. This will set the laser beam parallel to the tire contact surface. The target board adjustment wheel has 3 positions, and you should verify that it's set to position 2. Extend the mirrored arm of the target board until the forward laser beam is reflected from the reflective surface back to the front face of the laser assembly. Now, to get the target board set at a precise 90-degree angle to the thrust line of the vehicle, we need to make the laser beam reflect directly back into the opening in the laser assembly where it was emitted. To do this, start by carefully rotating the target board to move the laser beam on a horizontal path until it aligns vertically with the hole in the front face of the laser assembly. Next, use the adjustment wheel to raise or lower the beam until it's reflected directly and precisely into the opening. Once the alignment is done, be careful not to jostle the vehicle or move the target board. Do not place anything between the vehicle and the target board. And with the setup complete, you may now ignore the laser beam's position or turn the laser off. Now that the ICC target board is properly set, use Consult 3 Plus to align the millimeter wave sensor. Connect the vehicle interface to the vehicle and turn the ignition on, taking care not to disturb the vehicle. Open the Consult 3 Plus application and select Diagnosis, One System. Next, select Laser Radar from the system screen. Select the Work Support tab. Select Mill Wave Radar Adjust and then select Start. This screen should appear. If the screen does not appear within 10 seconds, the ICC target board is too close or too far away from the sensor, or is not properly aligned for the adjustment. The bumper fascia may have debris or dirt in the sensor area, or the sensor itself is not properly mounted. Select Start and follow the screen directions. You will be making the UD, up or down correction using the adjustment screw in the bottom of the millimeter wave sensor. The horizontal adjustment is performed automatically and cannot be adjusted manually. You will first be directed to set the target board to position 1. This is done by turning the wheel on the right side of the target board to the position marked 1. The position number should be visible from the front of the setting wheel. This will tilt the top of the target board 2 degrees toward the vehicle. Select Next on the Work Support screen. The Consult 3 Plus screen will indicate which direction and how many turns to make on the adjustment screw. Turn the screw the indicated amount and direction. The adjust value shown on the screen is not a live reading, so after any adjustment is made, you won't see any change in the value until the whole procedure is performed again from the beginning to check that the adjustment is correct. Now, select Next, and when the action is finished, the current status should show Complete. Then you'll be directed to set the target board to position 2, and then to make any adjustment if required. If the adjustment is correct, the UD correct value should show a double hash mark. The adjust value should be 0.00, and the current status will again show Complete. You will then be directed to set the target board to position 3, and similarly perform any necessary adjustment there. If adjustments were required, you will have 2 options. You can select Start to repeat the whole procedure for confirmation that your adjustments are correct, or select End if you have completed the repeat confirmation. The radar alignment procedure should be completed in one process. If this is interrupted or aborted, the ICC warning lamp will be illuminated, and the ICC system will be rendered inoperative. You will be following the ICC system action test as outlined in the service manual to verify the system is operating correctly after repairs and adjustments are completed. Finally, if you receive an error message at any time during the sensor alignment, you should check the following points. Battery voltage should be 12 volts or higher. Ignition should be on, but the engine should not be running. A DTC may be stored in the laser radar or advanced driver assistance systems, ADAS. The sensor mount may be loose, bent, or damaged. It may be necessary to remove the front bumper fascia and inspect the mounting of the millimeter wave sensor. If the sensor is grossly out of adjustment, use the sensor leveling tool to level the sensor, and then perform the alignment again using Consult 3 Plus. The millimeter wave sensor improves the safety and performance of intelligent cruise control, and aligning it correctly is another important step in maintaining the high quality of our service operations.